All right, welcome back, everybody. It's Friday, March 20th. I'm going to change gears a little bit here and talk about something called type 1 and type 2 error. It's really not math related, it's just kind of a definition, really. But what a type 1 error is when I reject the null when the null is true. So when I do these hypothesis test questions, at the very end, we always make a decision whether we're going to reject the null or fail to reject the null. And hopefully we make the right decision, but we're not really sure if we did or not. And there's a chance we made the wrong decision. We could have rejected the null when the null is true. So that's the wrong decision. That's an error. That's called a type 1 error. Or we could have failed to reject the null when the alternative is true. And that's called a type 2 error. So those are the two types of errors. And I grabbed this from the textbook, this little grid here, just to show you. So like this first box right here, it says reject the null when the null is true. We just said that's a type 1 error. So what I'm going to do is just write that in there, type 1 error. And that's good. That's reject the null when the null is true. Over here in this box, if the null is true and I fail to reject the null, well, that's the right decision. I did the right thing. The null is true and I didn't reject it. So we call that a type 2 error. I'm sorry. We don't call that a type 2 error. We call that a correct decision. We did the right thing. So that's a correct decision. Null is true, and we didn't reject it. Same thing down here. The alternative is true, and I rejected the null. So I made the right decision there as well. So I'm going to do here is just copy this guy and put that right there. So that's the correct decision. And the last one down here, the alternative is true, but I don't reject the null. Well, that would be the type 2 error. And that's what's happening with that guy there. So that's a type 2 error right there. So that's a little simple grid that shows us what's happening. Now, keep in mind, when we do these problems, we don't know if we made the right decision or not. We're just basing our answer on probabilities, right? If the p-value is low, we reject the null hypothesis. But it is possible that you just happen to get a low probability for that particular problem, and just by chance. So it is possible you reject the null when the null is true, right? That could definitely happen. So that's called a type 1 error. Usually in the context of this course, what we're going to have to do is interpret what the type 1 and type 2 error would be. So for this particular problem here, Haley has a company that makes peeps. The average weight of a peep is less than 5 grams. The production is stopped and the problem is addressed. So she works for a company that if the assembly line of peep production can show that the peeps aren't at 5 grams, they have to stop the whole process and then fix the machine and then restart the process. So the null hypothesis might be here that the mean is equal to 5. The alternative would be that the mean is less than 5. And the question is, what would a type 1 error be in the context of this problem? So remember what silly fonts drive me crazy. So type 1 would be we reject the null when the null is true. So the null is that the mean is 5. So we reject that. So we think the mean is less than 5. And in reality, the mean is 5. So we rejected the null. We reject this in favor of the alternative when the null is true. So we think the mean is less than 5 when reality the mean is 5. So what would the consequence of this be? If Haley's company thought the mean was less than 5, Haley will stop production even though the peeps are the right size. That's the consequence of a type 1 error. She'll stop production even though the peeps are the right size. That's type 1. Type 2 would be the opposite problem. We think the mean is 5 when in reality it's less than 5, right? So the type 2 error, would be we failed to reject the null when the alternative is true. So we think the mean is 5 when in reality it is less than 5. So what would the consequence be here? Well, Haley doesn't stop production even though the peeps are too small. of the type 2 error in the context of this problem here. So in this case, she thinks the mean size is correct, even though it's actually less than that. And the consequence here was Haley doesn't stop production, even though she really should. Oftentimes, I'll often ask you which of these is worse in the context of the problem. I would argue here a type 2 error is probably worse, right? Because she's shipping out peeps that are not the right size. So she's shipping out a product that's not good enough. Whereas a type 1 error, she does have to shut down the process and the company probably loses money, but it's not as egregious an error as type 2 error. Okay, so that's type 1 and type 2 error. I'll show you one other thing here, if I could, just to kind of visualize what this is. This might be a little more confusing, but if you think about it, this represents if the null is true, the distribution of the means, let's say. And forget the handwriting. This represents the alternative is true. So what I want to show you is they're both normal distributions. Suppose it's a right-tailed test. And what I'm going to say is, let's say this is my rejection zone. In other words, if I'm in this region right here, if my p-value is really low, I reject the null hypothesis. So that's going to be determined by whatever your alpha level is. In other words, if I call that alpha right there, remember alpha, if my p-value is less than alpha, I reject the null hypothesis. So if my p-value is less than alpha, I reject the null hypothesis. Now keep in mind what a type 1 error is. Type 1 error is I reject the null when the null is true. So that means I'm in that shaded region there. The null is true, so I'm underneath that black normal curve, but I'm in the rejection zone there. So the probability of a type 1 error is strict. That's terrible. That's supposed to be a 1 there. Is strictly determined by your alpha level. So whatever alpha is set at, 5%, 10%, 15%, that's going to be type 1 error right away. It doesn't change. It's whatever the alpha level is. Type 2 error, though, which we're going to call beta. I'll use a different color for that. Let's use green. Well, that's the probability that we fail to reject the null when the alternative is true. So I have to be underneath that purple curve there, but I'm not rejecting the null hypothesis. So really what that's going to be is everything to the left of this alpha level right there, everything to the left of that, but underneath the purple curve. So this is the type 2 error right there. So the alternative is true, but I don't reject the null. So I'm making an error there. That's beta right there. So it's a little confusing. And the third thing is something called power. Power is actually just 1 minus, I'll leave a different color here. Power is just 1 minus beta. So what power is a good thing. Power is the probability I reject the null when the alternative is true. So it's everything to the right of that green area in here. That blue area represents power. So those are 3 things: alpha, beta, and power. Now, we're not going to do much with these. I just want to show you kind of what happens. I have an internet thing I'd like to show you now. But again, the red region is type 1 error, alpha. The green is type 2 error, beta. And the blue is the power. So let me show you this thing here I have. Here's kind of an applet that shows us what's happening a little bit better, maybe. So the blue guy is the null hypothesis is true. The red guy is the alternative hypothesis is true. And you can see my alpha level right now is set at 5%. Beta is 0.484. So beta is this dark red region right here. And if I move these, which I think I could do, if I move these curves, let's say I move the red curve to the right more, you can see a couple things are happening. The type 2 error is going down. This dark red region is getting smaller, right? But the power is going up. The region from the dotted line to the right is getting bigger and bigger. So as I move this to the right, type 2 error goes down, power goes up. Alpha, by the way, type 1 error is staying at 5%. That's fixed. That doesn't change. That's always just whatever the significance level is set at. All right. So if I move this back to the left, you'll see the type 2 error goes up and the power goes down. What else can I manipulate here? Well, the sample size, right? we talked about earlier, if I make the sample size larger, the curve should get taller and skinnier. So I might make this 10 right now. We should see that the curves get taller and skinnier. Keep in mind, the alpha level should stay the same. That's set at 5%. But now type 2 error goes down because there's less of this red overlap right here, right? And if I make my sample size, where's sample size? Right here. If I make sample size 15, you're going to see even less of that dark red region and more of the power, right? So that's how I manipulate these things. One of the big questions they'll ask maybe is like, how can you increase the power easily? And the correct answer is just increase your sample size. That's the easiest way to do it. I could also increase my sample size manually like this, right? So you can see as I go up and up and up, the type 2 error is essentially 0 now, and the power is essentially 100% or 1. And there we go, right? Sample size goes up, it gets taller and skinnier. Sample size goes down, short and fat, right? So that's the idea. The key takeaway, though, is just recognizing type 1 error is rejecting the null when the null is true, and a type 2 error is failing to reject the null when the alternative is true. So I put a couple homework questions up here for you. And a hippopotamus, oh my goodness, it's a friendly hippopotamus. So from the textbook, page 727, 11.49, 11.50, please email me if you have any questions on anything. I'll be happy to go over it again, or I'll go over the homework questions if you have problems on them. But the homework's on type 1 and type 2 error. That's all for now. Be safe, everybody. Have a good weekend.